This is Module 4, Advanced Unreal Blueprints. In this module, you'll be learning about blueprint coding. You're getting about a semester's worth of academic content in this session in about 20 to 30 minutes. It's going to be tough, but I think you all can do it. Let's rock. In Module 4, we'll be covering the 8 topical areas as follows: variables, operators, functions, events, and macros, program flow, containers, data tables, latent functions, and finally, loading levels and quitting the game. Let's first talk about Unreal variables. Creating variables. Variables are used to store values and attributes in blueprints that can be modified during the execution of the game. The variables can be one of many types. To create a variable, go to the My Blueprints panel in the Blueprints editor and click on the plus button in the Variables category. Variable data types. There are several common types of variables used in Unreal. The first one is called the Boolean. It can hold either true or false. The integer value is used to store, integers. The float is used to store decimal values. The string or text type is used to store text. The text variable is preferable because it supports localization. The vector type contains float values of x, y, and z. It is often used in position in a game. The transform is used to store location, rotation, and scale of any object in the game. The details panel. When a variable is selected, its properties are displayed in the Details panel. This is where changes can be made to a variable's name and type. Other properties found in the Details panel include the following: Instance Editable, Blueprint Read-Only, Tooltip, and Expose on Spawn. The variable type property includes a button that is used to convert a variable into a container. A container can store several elements of the same type. An array is an ordered list of values that is accessed using an index value. A set is an ordered collection of values. Duplicate values are not allowed. A map is a list that uses a key value pair to define each entry. Duplicate key values are not allowed. Commonly in Unreal programming, you use the array more than the other two. When a variable is dragged and dropped into the event graph, a context menu appears with the options Get and Set. Get nodes are used to read the value of the variable, and set nodes are used to store a new value in the variable. They are useful shortcuts to create get and set nodes. To create a get node, press the Control key where dragging and dropping a variable. The set node is created using the Alt key. Let's talk about operators. There are 3 types of operators: the arithmetic operator, the logical operator, and the relational operator. The arithmetic operators, the plus, the minus, the multiply, and the divide, can be used to create mathematical expressions in blueprints. The image on the right shows a simple expression that adds a value of 50 to the current score variable. Then it sets the newly calculated value in the score variable. The plus and other operators receive 2 input values on the left and give the operation result on the right. To use more than 2 input values, just click on the Add Pin option. The input values can be entered directly into the nodes or can be obtained from variables. Relational operators perform a comparison between 2 values and return a Boolean value, either true or false, as a result of the comparison. The image on the right shows the relational operators, an example using a branch node. A branch node is like an if statement in traditional code. At the end of the game, the current player score, the score variable, is compared with the highest recorded game score, the high score variable. If the player's score is higher, The value of the score variable will be stored in the high score variable. Logical operators perform an operation between Boolean variables and return a Boolean value, either true or false, as a result of the operation. The main logical operators are as follows. OR returns a value of true if any of the input values are true, and returns a value of true only if all the input values are true. Not receives only one input value, and the result will be the reverse value. For example, if it was true, it's now false. If it's false, it's now true. The example on the right simulates a simple decision of an enemy in a game. Enemy is low on ammo, the low ammunition variable, and the player is nearby, the player is near variable. Then the enemy decides to run away. Functions, events, and macros. Functions allow a set of actions that are executed in various parts of the blueprint to be gathered in one place for easy organization and maintenance of the script. Functions can be called from other blueprints and allow the use of input and output parameters. To create functions, go to the My Blueprints panel in the Blueprint Editor and click on the plus symbol in the Functions category. There are several built-in functions that most blueprints contain. Event Begin Play runs when an object is added to a game automatically. Event Tick runs every game frame, and the construction script runs prior to Event Begin Play, sets up the object for in-game use. Functions allow for input and output parameters to be used. Input parameters are values that can be passed into a function. Output parameters are values that can be returned from a function. To add input or output parameters, select the function in the My Blueprint panel and use the Details panel. The image on the right shows a function with an input parameter named value that is added to the score variable. The result of the sum is set in the score variable, then is returned with the output parameter named newScore. Functions allow the use of local variables that are only visible inside the function. They are very effective in assisting in complex functions and do not mix with the other variables of the blueprint. To create a local variable, double-click on a function to edit it. Then look at the My Blueprints panel. At the bottom of the panel, you will see a category named Local Variable with the name of the function in parentheses. Click on the plus button in the Local Variables category. The target parameter is common to several functions and indicates the object that will be modified with the function call. The default value for this parameter is self, which is a special reference to the actor or object instance that owns the script that is being executed. The image shows different ways to use a target parameter of the destroy actor function. Unreal provides a number of predefined events, but it's possible to create new ones to use in a blueprint. These events can be called both from blueprints that they are defined in and other blueprints. To create a custom event, right-click in the event graph, expand the Add Event category, and select Add Custom Event. Selecting a custom event node allows you to manage the event name and input parameters. Events do not need output parameters. The image shows a custom event named Welcome Message with an input parameter called Name. The event will create and print on screen a custom message using the name passed as a parameter. An event has a small red square in the right corner that is known as a delegate. This is just a reference to the event. Some actions receive an event as a parameter, and using the delegate makes that possible. In the image shown, the delegate of the custom event named clock is wired to the set timer by event node's event input pin, so the clock event will be called every second. Another way to gather actions in one common place is to use macros. At compile time, the actions of a macro are expanded in the places that a macro is being used. Macros can have input and output parameters as well as several input and output execution pins. Let's now compare functions versus events versus macros. Macros, custom events, and function provide different ways to organize scripts. Each of them has advantages and limitations. One thing they have in common is that they all have input parameters. Macros have output parameters and can have many execution paths. They cannot be called from another blueprint. Events do not have output parameters. They can be called from other blueprints and have delegate reference. They support timelines. Functions can be called from other blueprints and have output parameters. Functions do not support latent actions, such as the delay action. Program flow in Unreal blueprints include the for loop node, the branch node, and the sequence node. The for loop node performs a set of actions that are associated with the output pin loop body for each index. When the for loop node completes its execution, the output pin complete is triggered. On the right, a for loop node is used to execute the print string node 10 times. The value of the input-output pin of the for loop node is used as the input for the print string node. The conversion node is automatically created by the editor when an integer value is connected to a string input. This is similar to a for loop in traditional programming. The branch node directs the flow of execution of a blueprint based on the value of the Boolean input condition, which can either be true or false. In the image shown, there is a custom event that is called at the end of the game. The branch node is used to test if the score is greater than 10,000. A different message will be shown based on the result. In traditional coding, this is the if statement. A sequence node can be used to help organize other blueprint actions. When triggered, it executes all the nodes connected to the output pins in sequential order. That is, it executes all the actions of pin then 0, then all the actions of pin then 1, and so on. Output pins can be added using the Add Pin Plus option. To remove a pin, right-click on the pin and choose the Remove Execution Pin option. Let's talk about the Unreal Blueprint containers, which are the array, the set, and the map. Additionally, structs and enumeration is also covered here. An array is an ordered list, and you can set and get its elements via the use of an integer-based index. The use of arrays allow grouping of variables of the same type. Creating an array in Blueprints is very simple. First, create a new variable and select the desired type. Click on the icon next to the variable type dropdown and choose Array. See the top image. After compiling the blueprint, it is possible to fill the array elements with default values as shown in the bottom image. The main nodes related to arrays are as follows. Get returns the element that is in the position specified by the index used. Length returns the number of array elements. Add adds a new element at the end of the array. And insert inserts a new element at the position specified by the index parameter. A set is a type of container similar to an array, but unlike an array, it is an unordered list of elements that are searched for based on their value. There is no index. It can be used to group variables of the same type. An important difference that sets do not allow duplicate elements. The key value used to find an item is the item itself. To define a variable as a set, click on the icon next to the variable type dropdown and choose Set. See the image shown. Following are some common nodes related to sets. Add adds an item to the set. Contains, check to see if the set contains the given item. Remove removes an item from the set. Length returns the number of items in the set. There is another type of container called the map. To define a variable as a map, click on the icon next to the variable type dropdown and choose Map. Each element of a map has a key associated with a value. A map is unordered and is searched using the key value. In computer science, this is normally known as a key-value pair. The top image shows a map whose key type is integer and whose value type is string. The key values of a map must be unique. In the bottom image is an example of a map where a number is associated with the name of a game item. A structure can be used to gather in one place related variables. The variables that belong to a structure can be of different types. We can also have structures that contain other structures and arrays. To create a new structure, click on the green Add New button in the content browser, and in the Blueprint submenu, select Structure, rename it Item Struct. Double-click on Item Struct to edit it. In the My Blueprints panel, click on the plus button in the Variable category to add variables to the struct. As an example, create a new variable in a blueprint that represents the inventory of the player. Name an inventory and use the variable type item struct which was created previously. Click on the icon next to the variable type dropdown and choose Array, and then compile the blueprint. New elements can be added to the array in the default value section of the Details panel for the inventory variable. Each element will contain the variables defined in the item struct structure. When a structure is referenced, the break and make nodes become available for use in the blueprint. The break node receives a structure as input and separates its elements. The make node receives the separate elements as input and creates a new structure. The image shows the break and make nodes of the item struct structure. When a structure is an input or output parameter of a function, its pins can be split to create an output pin for each element of the structure. To do this, right-click on the struct pin and choose Split Struct Pin. For example, a vector in a blueprint is a structure containing 3 float variables with the names x, y, and z. The image shows the getActorLocation function with the struct pin and the pins for each element of the structure. An enumeration, also known as enum, is a set of constants with meaningful names that specifies all possible values a variable can have. To create a new enumeration, click on the green Add New button in the content browser, and in the Blueprint submenu, select Enumeration. Double-click on the enumeration that was created to edit it. Click the New button to add the names that were part of the enumeration. To create a new variable using an enumeration, just select the name of the enumeration in the variable type dropdown. The top image shows an enumeration name eWeaponType being used as the variable type. Set the instance editable property to true so that the value of the enum can be chosen in the level editor. The bottom image shows the values that can be chosen for the enum variable. There is a type of switch node that determines the flow of execution in accordance with the value of the enumeration. In the image shown, weapon type is an enumeration variable and weapon mesh is a static mesh component. The static mesh will be set according to the type of weapon. A data table can be used to represent a spreadsheet document. This is useful for data-driven gameplay. To create a new data table, click on the green Add New button in the Content browser, and in the Miscellaneous submenu, select Data Table. After creating a data table, it is necessary to choose a structure that will represent the contents of the table. See the top image. Once a new data table is created, double-click on it to edit it. The example shown is using a structure with the variables strength, dexterity, and intelligence. This data table has 3 rows, each one representing an RPG class. A variable can be created to represent the data table in Blueprint. The function getDataTableRow uses the row name parameter to return a line of the table as a structure. The breakStruct node can be used to access the attribute of the struct. The delay function is a latent function that performs the action connected to the completed pin only after the time specified in the duration parameter has elapsed. Latent functions do not follow the normal flow of execution of the blueprints. They run in parallel and can take several ticks until they complete. The example shows a custom event called spawnEnemy that has a delay function to ensure that at least 5 seconds have elapsed before it spawns a new enemy actor. Even if the spawnEnemy event is called again in less than 5 seconds, the delay function does not allow the creation of a new enemy. Play in the editor to see the time remaining in a delay function. See the example. The retriggerable delay function is a latent function that performs the actions connected to the completed pin only after the time specified in the duration parameter has elapsed. The difference between the retriggerable delay and delay function is that the countdown value for the duration parameter will be reset if the retriggerable delay function is called again. A timer is programmed to perform a given function or custom event after a specified time has elapsed. 2 functions define a timer. setTimerByEvent has an input parameter which is a reference to a custom event. setTimerByFunctionName has an input parameter which is a function name and the object that contains the function. Both functions have the following parameters: time, which represents the length of the timer in seconds, and looping, which indicates whether the timer will continue its execution or execute only once. The openLevel function can be used to load levels in a game. The value of the level name parameter can be the folder name plus the name of the level. If the openLevel function does not have the full path, it will try to open the first level, a UMAP, it finds with a specified name. If there are multiple UMAPs with that same name, it will choose the first one it finds. The function can be used in a blueprint when overlapped by the player will transport them to another level. It can also be used in the game start menu where different levels can be loaded based on the chosen option. The quit game function can be used to exit the game or move the application to the background. To summarize, this module showed how to create variables and how to use operators to create expressions. Functions, custom events, and macros were presented, and the lecture introduced some basic nodes that control the program flow. Finally, containers, data tables, latent functions, loading levels, and quitting the game were presented. Please complete the Module 4 lab assignment and multiple choice quiz. Thank you.